Welcome to the Design Specification presentation by the SunView Software Group by Adrian Borrego, Alex Alava, Luis Dominguez, and Brian Uzan. First of all, we would like to thank Tom Lumia and the machine learning engineers at SunView Software for their insight on the project. We would also like to thank Dr. Christensen for his input and suggestions. The agenda for this design specification presentation is the following. First, we're going to start with the background information relating to the project, followed by a full description of the problem, the project requirements, the project design and specification, an analysis of the design, and an overall project plan. For the background information, we have that an automated chatbot is a computer program that simulates the conversation of a human being via text or voice interactions. A user can ask a question or make a command, and the chatbot will respond or perform the requested action. These chatbots are implemented through machine learning, which is programming a system to learn from and make predictions based on data. Given a large dataset, a machine learning bot can become quite adept at understanding a user's intent. Text classification also makes it simpler to understand the user intent by systematically tagging a text input with its most important key phrases. By using these two technologies, it is possible to configure a chatbot to provide the appropriate response. The problem addressed by our requirement is: can machine learning techniques be used to implement a chatbot capable of using text classification to correctly categorize a query into one of 24 different categories of technical and non-technical queries, and to provide an appropriate response with at least 75% accuracy? The requirements for these projects are: Number 1, the bot should be able to correctly categorize user input into one of 24 possible tags with at least 75% accuracy after asking for clarification. Number 2, when confidence for text classification is 40% or lower, the bot should be able to ask for more information. If the bot is still unsure after checking, it should return, "Sorry, I don't know." Number 3, the bot should function with a non-graphical user interface, for example, a command line interface.
The flow of the design is as follows. Test data is gathered or manually generated. In our case, this test data consists of possible queries users make to the bot. These queries can be either technical or non-technical, and some clients like to jokingly ask a bot questions about feelings or vacation holidays. To function with the text classifier, test data must be composed of a plain text one-sentence query with a customizable matching prefix label. The query is analyzed by the model for essential keywords, and these words are associated with the labels provided in this test data. This test data is fed through a machine learning text classifier which produces that model that maps keyword associations with possible categories the bot can respond to. A user input is then fed into the model, and its closest category is returned with a confidence value measured from 0 to 1. If confidence is sufficiently high, the bot produces the model's desired response. This fulfills requirement 1. Otherwise, if confidence is not sufficiently high, the bot asks the user to clarify their input. This fulfills requirement 2. Text classification works as follows. The input query is fed into the trained model. The model determines if the query is technical or non-technical, and then categorizes the query. If the query is technical, the bot provides a useful link to help the user. This link can be configured by the bot's developer, so any company using this bot can customize its functionality to fit a specific need. Otherwise, the bot will provide a canned response to play along with the user's non-technical query. Here is a depiction of the bot's expected behavior. In this case, a user query is clearly not technical. The user is asking, "Are you real?" The text classification model identifies the appropriate topic with strong confidence, this category being self-awareness. The bot provides the proper response and returns the prompt to the user for another query. This is a depiction of another case, in which the bot does not have sufficient confidence to make a definite categorization of the user query. Here, the query is unclear or possibly vague. The bot makes a guess and asks the user if it is correct. If the user answers affirmatively, the bot provides the guessed information. Otherwise, it will respond, "Sorry, I don't know," and ask for another query.
This chatbot would be an improvement over SunView's current self-service help desk. The ability of the application to discern between technical and non-technical user queries would fill a small but important gap in their service desk software. FastText was chosen as the library used to generate and train the machine learning model for the application. This free and open source library provides a lightweight environment which allows for quick text classification. The models generated work properly on standard and generic hardware, and can even be reduced in size to fit on some mobile devices. For these reasons, FastText was chosen over other open source libraries that provide similar functionality, such as convolutional neural networks from TensorFlow and recurrent neural networks. Additionally, Microsoft Azure Cognitive Services provide a text classification suite with cloud infrastructure and formidable accuracy, but is proprietary and has some costs. One of the assumptions imposed by SunView software is that all code must be open source, so this definitely takes Microsoft product out of reach. It was decided that the chatbot will be accessed through a command line interface. The graphics for the chatbot will be adjusted later in development by SunView in order to match their specifications. As we can therefore conclude, our development is solely devoted on the chatbot's functionality, accuracy, and efficiency, rather than designing a graphical user interface.
Here we will be taking a closer look at our project timeline and focusing on the main stages of its lifespan. These stages consist of product specification, design, implementation, and testing, which will be covered over a course of 3 months throughout the project's lifespan. This week we began looking at our design review in order to get a better understanding of project specifications and set deadlines. Next week we will receive our design feedback, which will help us also better understand our faults and maybe make any updates necessary for the requirements or /deadlines. We have already begun implementing the fast text classifier, which will allow us to build an initial model from the updated training set received from SunView. Since having a lot of data is crucial to building a strong model, we will be updating this training data all throughout the semester. As you can see, the training data is updated in the beginning of February and extends all the way towards the third week of April. Starting March, we will be optimizing the model and finalizing a prototype for April 16, meeting the set requirements. The final presentation, along with project poster and mini press release, are also expected to be finalized and submitted by May 2nd.
Thank you all for your attention. We really hope you enjoyed our presentation on SunView Software Chatbot. We're open to discussion and to any questions that the audience might have.